Okay, the recording has started, and let's go back to our in-class problem. Okay, so number one, straightforward. Take a look at it. Look at it and determine what is going on there. Are there numbers on the integral bar? No. Therefore, this is a general answer. It's an indefinite integral, it's called. It's indefinite because a and b aren't given. And as a result, a plus c is needed on that function when you're done. Okay? So in a second, I'm going to go ahead and put that on my iPad. Okay, let's go to my iPad and do that one. All right? Okay, and I also have I have the chat box up. If you've got something, make sure you speak. Feel free to speak up, let me know, or whatever the circumstance is. But let's do this problem now. So this is just straightforward. Coefficient x to a power minus 4 times x. That's a straightforward polynomial type arrangement. So the integration, we need to take the antiderivative of each term. As a result, we end up with, so this is actually equal to, people, make sure you use equal signs. This last test is finally to the point where I'm going to say, if you don't include equal signs in your answer to show mathematical equivalence somewhere, you know, I'm going to make a point to take something off because it's a correct answer if mathematical equivalence requires equal signs. Also, when you start taking derivatives, you know, you need to use a derivative symbol. If you're given f of x, then you need f prime of x, etc. Those type things. So let's start this problem now. So I need to take the antiderivative of 3x squared. So that means I've got to work with the 3. And I'm going to have the x raise the power by 1 and divide by that new power. Minus 4. Raise that power when there's not 1. It's distracting sometimes, but there's a 1 there. Raise that power by 1 and divide by that new power. This is an indefinite integral, so I don't need an integral bar after it, but I do need a plus c. And the only thing on this one is I need to simplify, okay? Assume all the way through that you need to simplify your final answers. The 3's cancel here, we get x cubed. The 2 goes into the -4, we get minus 2x squared plus c. Answer. All right? Take the derivative of that and make sure you get the problem that you're given. Every time. Be confident. Okay? And I encourage you to do that. You're going to have time on the test. Okay? Every time. All right? Now take a look at number 2. A little different one now. I want you to stop and think about, pay attention to, when you look at the problem, things to catch, okay? The integration bar. There's a 1 and a 2. This is a definite integral. The answer is going to be a number. It's going to be a value, okay? And I don't need a plus c on this one now. So I don't need to include plus c in solving the problem. Because if I did it correctly, I'd have a plus c in the first part and in the subtraction part, so they would cancel each other out. And another thing now to notice algebraically is that we've got a fraction, it's a rational function, and notice the denominator, okay? There's a single term down there, all right? So this being a rational function, it could become a more complicated circumstance, and you could look at it a certain way of a variety of different things. You check to see if it's substitution. Do you have to use some other circumstance? But one easy way of solving this problem is to distribute that fraction into being 2 fractions. That simplifies the problem a great deal, okay? So let's go back to my iPad and look at that problem now. Okay, so here's the problem. And the idea is, let's split this into 2 fractions. So we've still got 1 to 2 equal signs there. And now inside the parentheses, I'm going to have two fractions. The x goes under the 1, okay? And then the x goes under x squared, which simplifies to x, right? So let me save ink or marker on this iPad and recognize that that x squared over x is equal to x, okay? Now this is the x. That's the same thing as the original function. Any questions on that at all? Okay, also, you guys, you need to start getting in the habit when you're doing integration. 1 over x is a significant thing. It shows up, okay? If you don't catch it and don't remember it necessarily, natural log is a part of that deal. If you write it down as x to the negative 1, all right, and you integrate it, you raise the power by 1, it becomes 0, and you divide by 0. Have that, I've said this before, have that be a flag, okay? If you don't happen to remember it and you make it x to the negative 1 and you start getting zeros, understand that that's the special case. That's natural log, all right? Okay, so let's go to the next step. And several of you that have written your answers out, I think many of you that are here haven't been doing this necessarily, but those of you, if you're catching the recording, pay attention to, I'm going to use the integral bar now, and it's an important part of the problem. If you don't include it, it's not written correctly. If you go to the next step and you write the antiderivative, a part of the solution is you know what A and B are, the limits of integration. They're an important part of the answer. So that's part of the next step. We need to make sure we include it. So the integral symbol out front goes away, the dx goes away, and now we integrate 1 over x, and that is natural log. And we got to remember now, absolute value of x is a part of that circumstance because it can't be negative. 1 over x can be negative, but natural log, that x value has to be positive, okay? Okay, and as a result then, so that's the first term, plus the antiderivative of x to the first. So raise it to the second power and raise the power by 1 and divide by that new power. This is being taken to, the a and the b are being integrated over 1 to 2. All right? So this is part of the solution. And if you want to write brackets around it and put the 1 over and 2 on that, that's fine. But be careful. I saw a couple of you did it on the parentheses. And remember, that can get confusing if you've got an exponent up there on the parentheses also, that 2 up on the parentheses could be distracting, or it could be, or if there's another exponent, it could cause problems. So somehow getting the bar, I think, worked better. It's always worked better for me, but however you want to do it is cool. Okay, so now we got to plug in, now we need f of b minus f of a. Cap f of b minus cap f of a. Let me write that down. The fundamental theorem of calculus, the integral of lowercase f of x dx is equal to cap f of b. Let me make sure. I've got a crossbar that looks like it, that f became a cap f. It gave me a lowercase. Let's hit this. So this is equal to cap f of b minus cap f of a. Okay, so the next thing we got to do is then plug in 2, both cases. So I've got the natural log of 2, since it's positive, I don't need the absolute value signs, plus 2 squared over 2. There's my f of b, minus, all right, and now you do need the parentheses because there's more than one term. It's going to be the natural log of 1. And if you've got that going already in your head, if you know what that is, that's going to be a 0, right? So that's going to be an important part of it. And then you've got plus 1 plugged into the function. So we got 1 squared over 2. All right, now let's improve one thing in each spot at a time that we can. So equals is an important part of the correct, good answer. I tell you what, both of these are positive, so we don't need the parentheses anymore. That's the natural log of 2. If you want parentheses around that, you can, but they're not crucial. Plus 4 over 2 is 2. And now this distributing the minus sign is going to be important. So because I didn't simplify it on the first step, now I need to recognize natural log of 1 is 0. And then we've got plus 1/2. And this is one of those situations where it's crucial that we distribute that minus sign, because it makes that 1/2 negative, okay? It makes the 1/2 negative. So it's crucial that you have the parentheses and you apply it, distribute it. So that equals the natural log of 2 plus 2 minus 1/2, huh? So that means I need 4/2 minus 1/2. So that does become 3/2. Okay? This is a definite integral. Let's check it on our calculator, okay? I'm going to check on the calculator right now and see if we get, it's not going to read natural log of 2 plus 3/2, but if I asked you for an exact answer, this is it. But if I wanted you, if I said round it to 4 decimal places, let's see what we get. I get the natural log of 2. So I've got the natural log of 2. I get 0.693, yada, 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 plus 1.5. And I get so the answer to this is 2.193147. And if I said round that to 4 decimal places, you know, look at that, is that, now this is a good one to talk about, okay? Because some people have it still in their head that 4, the next number is a 7. So I would round that up to a 5. But therefore I would round that 1 up to a 2. That is not correct. The correct situation is you look at that number right now with all the decimals there and look at that digit right now. Is that number a 5 or above? No. That means you round down, okay? If you rounded that up to a 5, it's, you know, the number, if you were asked to go to 5 places, then it would be 1/5. That's correct. But that would be cause rounding error on the next part because it's the number is below 5. You know what I'm saying? So let's put it on our calculator now. So what I've got to do is you got to be careful with how you denote it, especially if you are doing a TI-83. I'm doing a TI-83. If you got a TI-84, feel free to do it. Math 9. Now I'm going to need to write, let's write the original function like it is. Parenthesis on the outside, okay? I need parenthesis on top because I'm going to have that 1 plus x squared over x. So I've got 1 plus x squared, close parenthesis, divided by x. Okay, now that's my function. I've got parentheses around 1 plus x squared, close parenthesis, divided by x, comma. Then I need my x for the variable of concern. And then I need the limits of integration, which are 1 and 2. So I need a comma, 1, comma, 2, close parenthesis. And I get the 2.193147 that I got from natural log plus 3/2. So be conscious of it. If you haven't written it as a decimal, you know, you'd get 2.193147 yada yada on your calculator, and wouldn't know necessarily that that's 1.5 plus natural log 2. Just be conscious of it and take in consideration everything. But that is the correct solution. Okay. So on that answer, I didn't ask you for anything specific. So any way you put that will be fine. But if you put the decimal to 4 places, that would be good. I wouldn't round it to 1 or 2 places. The inaccuracy is pretty strong there. But going out to 4 places or something like that would be cool. Or you could write it in an exact way of natural log of 2 plus 1.5 or plus 3/2. Okay? Questions?
Yeah, real quick. So if you were to then write this as its antiderivative form in the function, would it be capital F prime of x and then the natural log of absolute value of x plus x squared over 2 plus what we now found as c?
Okay, so you're saying that the cap F, you're referring to using this notation? The cap F is, I'm going to box it right now on the screen. This is your cap F. The natural log plus, natural log of x plus x squared over 2, that's cap F.
Okay.
And
Gotcha.
and the bar is indicating what B and A are. So on the next step, this right here is cap F of B, and this is cap F of A. Finding the difference.
Okay.
Okay, good. Oh, and Mark asked the question a little earlier, and I want to just say something to everybody here. The whole thing is, the idea is that You know, on one question, we were talking about area underneath the x-axis. And there are some people in some situations, if you're talking about vector math, then you can have a negative area or something like that. But if you're looking at a triangle in two-dimensional space, and you're just asking what's the area of that, the answer is positive. All of the sides are positive. And therefore, any formula you use would be positive. You have to get into some special circumstances, vector analysis or whatever type circumstances, to cause special considerations that might give you a negative. So the area of the triangle under the x-axis is positive. If you're asked what's the area of that triangle, it's positive. But if you're doing a calculation of area above and area below, then you've got to consider the area below to be a negative value that'll be taken away from any area that's above. So if you have questions about that, we can talk about that more. Let's go on. I want to keep moving here. And any other questions about that?
Hey, can you just clarify which one is A and B for like f of B minus f of A, like terminal minus initial, either the 2 is B or the 1 is A? I'm kind of confused on
So
that.
the situation is always this. A is at the bottom. In our designation, A is at the bottom, B is at the top. So in this case, this is f of 2 minus cap f of 1. Okay?
All right, sweet. Thank you.
Again, A to B, going smaller to larger, is the typical arrangement. Remember, if it was the other way around, it's the negative of it. So, and there's some situations where that's going to show up. You need to be able to catch that. And yeah, so it's just, sometimes it can be confusing, but I'm going to keep things pretty basic right now. Okay, let's go to number 3. Here's another situation we haven't dealt with before. Oh, we kind of did, but it's got to do with a fraction and a negative on the x, okay? So let's look at this now. This is the integral, indefinite integral. So as I'm writing, I'm remembering I need to make a plus c on this. Before I'm done, I need to put a plus c on it. So even if you don't include it when it first should show up, as long as you put it in your answer, the plus c will be accepted, okay? It'll be correct. Okay, so on this one, you guys, this is a special case because of the fact that we've got a radical. That means there's a fractional exponent, and it's in the denominator. Therefore, it's a negative exponent, negative fraction, okay? So first thing, let's read. It says determine the indefinite integral is what we're trying to do. So that means plus c. Okay, so I'm going to rewrite this as 8, move this upstairs, and rather than move it upstairs and take another step, I'm going to go ahead and convert it at the same time to x to the negative 1/2, okay? So that's x to the 1/2 at the bottom, and it's x to the negative 1/2 on top. Everybody okay with that? Okay, and if you want to do that one step at a time, feel free to make sure you're solid on it. That could be rewritten as 8 over x to the 1/2, positive 1/2 on the bottom, and then when you move it upstairs, it becomes negative 1/2. That's fine. But if you already got it, then feel free, it saves you a little pencil lead. All right, and now we're ready to take the antiderivative. We had to make an adjustment, get rid of the radical, get a negative exponent up there. And remember, it started as a radical, so I want you to end your answer with a radical. Assume that's going to be part of what I'm expecting, okay? So what we now got to do now is we're going to raise the power by 1. So I'm going to bring this down to the next line. The integral symbol goes away, and the dx goes away. The 8's there. X is now, I'm going to go ahead and write it out as a positive addition of 1 with a base of 2, a denominator of 2. So that's x to the negative 1/2 plus the positive 1, right? And I've got to divide by the new exponent, which is going to be negative 1 plus 2 is 1/2. It's going to be 1/2. So I've got to divide by 1/2. Positive. Okay? Remember, the new exponent is going to be positive 1/2. You divide by that new exponent. Okay? And this officially is when the plus c starts showing up. All right? So let's rewrite this. I'm going to flip. Now remember, the 1/2's in the denominator. I'm going to flip it, move it up top. That's going to make it 2 times 8. So that's going to be equal to 16 out front. times x to the 1/2 plus c. And the end result of this now is that I can just simplify this to, I said ended it with a radical. That means I've got 16 x to the square root of x plus c. All right? And for a second, before you take it back to a radical, now would be the time to look at this stage when you can take the derivative of it and make sure it takes you back to what you started with. So if I took the derivative of that, I'd bring the 1/2 down front, multiply the 1/2 times 16, that gives me 8. And I got to subtract 1 on the exponent. Therefore, I've got negative 1/2, moves it to the denominator. Yahtzee. Okay? Any questions on that at all? So the final answer I would ask for is right here, returning it to a radical. Okay, any questions on that? Okay, I tell you what, rather than going back to the other screen, let's go ahead. I'll write the problem right here and just take care of this. That's a 2. I'm talking and chewing gum at the same time, and that's almost painful sometimes. Okay, t squared dt. All right? So notice, indefinite integral. Got to add a plus c. Okay, now about the function itself. One of them's got the notice it's a t instead of an x. Your answer needs to be in terms of t. If you change them to x's, you can do that if you want to. It's a common familiarity. But the circumstance is that your answer needs to be in terms of t. So notice that there is 1 t in the denominator of that first fraction. That is t to the negative 1. If you brought it up, raise the power, goes to 0. That is natural log. That is a natural log function, 3 times 1 over t, if you want to rewrite it that way. The second one has got t squared down there. Therefore, we're going to bring that upstairs, make it a negative exponent. The first one, you bring it upstairs, it would give you negative 1 up there, and you take the antiderivative of that, you get 0, and then you got to divide by 0, and that's the flag. That's natural log. Okay, so another way to write this, if you wanted, let's tell you what, I'm going to rewrite this as, this is the same thing as, we haven't started integrating yet, but I'm going to write it as 3 times 1 over t, and I'm going to rewrite the second one as 2t to the negative 2 dt. Again, don't start taking the antiderivative of one term. If I know that's natural log, go ahead and, if I wrote natural log there and I didn't take the antiderivative of the second one, that mathematics is not correct, okay? You need either to do the whole thing or you don't do any of it, all right? So what do we have? Okay, we're ready to start integrating now. I've got negative exponent. I've got it in terms of natural log ready to go. So this now, the integral symbol goes away. I've got 3 times, okay, this is natural log, absolute value of t, minus, the 2 is there. I've got to raise the power by 1 and subtract by that new power. Negative 2 plus 1, that gives me negative 1. I've got to divide by the negative 1. And you guys, it's really important to make sure you keep track of your minus signs here. So you're going to have a negative out front where you're subtracting 2t. You've 2 in front of the 2, and you've got a negative exponent, and you've got a negative in the denominator. So you've got to remember, they mean different things, okay? But you've reached a point now where a plus c officially should be showing up, all right? So the first term is all set, done. Can't simplify that at all. But now I've got a minus sign subtracting out front. And in class, I'd be asking you guys, okay, what can you tell me? What am I doing next, you know? And one of the minus signs is changing that sign that's out front, you know, that minus 2, that negative 1 underneath makes it negative. You're subtracting a negative, that makes it positive. So this becomes positive, and this negative 1 at the bottom goes away. And what I have left is 2t to the minus 1 plus c. All right, so that ends up giving me 3 natural log of absolute value of t plus 2 over t plus c. Answer. Okay, notice the answer. Look back at what was given in the problem. And if you take the derivative of natural log, what do you get? 1 over x, 1 over t. So that gives us 3 times 1 over t if we took the derivative. We've got a -1 on the bottom. If you took the derivative, that would give you -2, and it would also bring the negative down front to make this negative. So check it. Make sure your signs are right, you guys, across the board. Any questions about that one? Okay, I tell you what, I want to go to a fresh screen. Hey, those are all kind of fair game questions, little segments. I'm probably going to give you indefinite integrals, definite integrals, and just like I did on the test before, I gave you a derivative sign, a function. It wasn't just a function, but then it had a bunch of things you had to take the derivative of. I'm probably going to do that too with the antiderivative. You're going to need to do antiderivatives of individual terms, and so be ready for all of them. Okay, so let's go to number 5 now. This is kind of interesting, I think. It's kind of a cool part of the problem. And if let's look back at I'm going to go back and look at the problem myself here. So if I go to number 5 here, notice what it's saying. Calculate the exact area. Calculate the exact area between the curves of y equals x squared and y equals 2 minus x squared. Okay, stop and think. What do those look like? Look at it yourself. You all know what those look like, at least a glimpse of it. One of them is x squared, a parabola going through the origin. Look at the second one. What is that? Parabola. Negative x squared, upside down, moved up. It's just like x squared, except it's minus, but it's been moved up 2 spaces. Okay? So it's asking, calculate the area between those 2 curves. What? We're not given anything, but I give you the instructions. Write the problem using integral notation. Use the fundamental theorem of calculus. Solving your answer. Check it on your calculator, but we're going to do the problem otherwise. So let's take a look at this. I've got this on my iPad. And look with me on there if you would. I'm going to switch over to my iPad.
Do we have to come up with our own limits of integration on a problem like this?
Yeah, good observation. That's exactly right. Because it says to use the integral. That's exactly correct. And so you're going to need to find out from the 2 functions, where do they overlap? And you will see then what the region is going to determine what your limits of integration are. Excellent question. That's exactly right on. Okay? So let's take a look at this. We've got y equals x squared and y equals 2 minus x squared. Right? Well, y equal x squared is 0 over 1 up 1 over 2 up 4 over 1 up 1 over 2 up 4. So the y equals x squared looks something like this. Okay, that's y equals x squared. Okay, let's do y 2 minus x squared. So minus x squared is just flipped and moved up 2 places. You could go through the process of plugging in 0 if you want to, plug in 1, -1, and plug in 2. But what I'm going to do is I'm just going to flip the fraction and move it up 2 places. So that means I've got to start here. If I plug in 0 for x, I get 2 minus 0 equals 2. Plug in 0, I get 2. Over 1, down 1, over 2 to the right, down 2, over 2, down 4, right? I saw down 2 underneath the x-axis. And in this situation, we're going to the left 1, we go down 1. Notice it overlaps exactly on the point of the other one. Over 2, down 4, puts me there. So I've got a parabola that looks like this. Okay, pardon that sketchy little drawing. But look, where do they overlap? Where do they overlap? So what the question says, find the exact area between those curves. So it's asking for this. And by looking at where we graphed, you can look at the graph. If you got a graph going, you can tell what the limits of integration are. You're worried about x. The lowest x ever gets of this area we're concerned about is -1. And the farthest it goes to the right is +1. Okay? And therefore, the integral that we're going to take the area, we want the area under the curve. Take a look at this now. I want you to see this, though, first. Take a look at this. If I've got a function that it looks like this and this, okay? When I take the antiderivative of it, I'm getting the area under the curve, right? So that means I'm getting this between the curve and the x-axis, right? I'm getting that. That's what I'm getting, down to 0. Okay, and that's for y equals 2 minus x squared. Now, if I'll now draw the other one, okay? When I take the antiderivative of this one, I'm getting the area between -1 under here and up to 1 over here. So that's taken away the space that's not in the area we're concerned about. So what we've got is, all we've got left when you do find the integration, you're finding the area under the curve, you've got the entire area, and then when you subtract off the x squared, that's going to give you, it takes away the area under the area that we're concerned about. That's above the x-axis. Those two little regions here. It would get rid of it. So the order is important, how you write it down. So it's going to be the integral goes from -1 to 1. We did that from the graph. We'll do it algebraically in a second. Of what? The one on top we need to take first, which is 2 minus x squared minus the one that's on the bottom, x squared dx. Okay? Let's say, and also though, you might have situations sometimes, this one's really straightforward, over 1 up 1, over down, over 1 down 1, turns out to be -1 1. Well, what could you do to figure out algebraically what those numbers are? Well, notice that is where the two functions intersect. Therefore, that is where x squared equals 2 minus x squared. And solve for x. That's what you've got to do. Where does one function equal to the other? That's where they're going to intersect. So in this case, let's get the x's over to one side. I got to add x squared. That gives me 2x squared equals 2. X squared equals 1. That means when I take the square root of each side, I got to do plus or minus, right? So I end up with x equals plus or minus 1. And you would get that in a different format if it was a different type of problem. But that is the foundational part of, if you can solve it algebraically, if you didn't have a graph of it, you can do the math of it. Where are the two functions equal? That's where they intersect. Okay? So now, before we do anything else, let's simplify this function, because I could take the antiderivative right now, but I've got 3 terms in there. If I combine those x squareds, I only have 2. That'll simplify it a little bit, right? So that means I've got the integral. This equals the integral from -1 to 1 of 2 minus x squared minus x squared. That's going to be minus 2x squared dx. Okay? And now we're going to get an answer, and you'll be able to plug this in your calculator to verify it's right. Okay? So let's do it. So we end up with, now we're integrating. There's 2 terms. I got to raise the power by 1. That first term is a constant. Notice that. It's a constant, so therefore I got to attach an x to it. And I've got, it's a definite integral, so the answer should be a number. Okay, so we end up with this. I end up with the integration bar goes away. I end up with 2 and you multiply it times x, minus 2, raise the power by 1 and divide by that new power. All right? And this is where I made the comment, you would add an integration bar to indicates the limits of integration, the values that are a and b that you're going to plug into the function. If you don't include that, I'm going to take something off. It's not mathematically correct. If you haven't, it's cap f, but you need a and b as a part of the solution. That's part of a correct answer is including a and b, right? So now we got to plug in plug in b first, right? And that gives us, so we end up with, I need cap f of b minus cap f of a. So that is cap f of 1 minus cap f of minus 1. And again, you guys, we got to subtract. There's a minus sign in that cap f, and there's a minus sign in a. You got to keep track of your minus signs, okay? So let's go. Cap f of 1 is 2 times 1 minus 2 times 1 cubed over 3. That's f of b. Then I got to subtract f of a. 2 times minus 1 minus 2 times minus 1 to the third over 3. Boom. There's no plus c. There's a plus c after this one if you wanted to, and then there's a plus c after the other one. It's got a minus in front of it, so they both disappear. And now it's just a matter of simplifying, okay? Notice fractions show up. A lot of times when you integrate, you're going to get a fraction, a number in the denominator that is going to cause you to have to work with fractions. So let's see what we get here. I got 2 minus 2/3. No need for parentheses on that. They're both, the outside parenthesis doesn't have a negative in front. But now I need to keep a minus on this. I've got -2. That I'm going to keep the minus sign and multiply this out. That -1 cubed is -1 times 2. That's -2 over 3. Questions on that? That equals 2 minus 2/3. All right. And now I'm going to keep the sign subtraction just for one more term. I'm going to, just to make sure I've got everything squared away here. That's plus 2/3. And now I'm going to distribute the minus sign. So I've got 2 minus 2/3 plus 2 minus 2/3. Isn't that special? And that gives me 4 minus 4/3, which is, what is that? 12/3 minus 4/3 equals 8/3. And if you do that on your calculator, it should be what? It goes in there twice with 2 and 2/3. So that's 2 and 2/3, which is 2.6 repeating forever. Okay, let's do it on a calculator and make sure it's right. All right, so let's go back and input this, the simplified version. Put that into your calculator right now, if you would, okay? If you got a TI-84, get your integral, do math 9. Math 9. And if you've got the TI-83, then you need to input 2 minus 2x squared, 2 minus 2x squared, okay, comma, for the TI-83. And then we got to put x, you got to put a dx in there on your TI-84. And then we got from -1, not minus sign 1, make sure you use the negative from down by the decimal point. And I know you know that, but it's sometimes when you're taking tests and learning new stuff, things fall away like that. From -1 to 1, close parenthesis, hit enter, and 2.6666666 is what I get. If you didn't get that, then check it out. You might have input something wrong, okay? Any questions on that? Okay, so that is it for the in-class problem. It was meant to review some key concepts, introduce the idea about two different graphs. How do you find the area between them? That's a situation that could be a fair game question. If it doesn't show up now on the test, it could show up on the final exam, okay? And I may put a simple one on the test, okay? So make sure you get the logic of that and get that down. Any other questions about this at all? Any of those 5 questions? Okay, I tell you what, there's one other thing I want to mention that we haven't really talked about. Let's go, I want to show you something here on my iPad. They've got it in, they've got examples that they show in the sapling problems. But one of the things that I want to point out is how you can look at the integration function. If you remember, when we had the diagram of the the velocity function and we drew the rectangles under the curve, all right? Well, notice what the curve was. The curve was the velocity. The velocity was the value that the function was. And the area under that curve, it turns out to be the amount of change, okay? So the velocity was a rate of change, and underneath that curve is the amount of change that happened. So how far it went from the start time to the end time. And as you move from left to right, that is increasing, and it's kind of, as you're moving to the right, it's building up. As the distance is increasing, as you go to the right, the distance is, it's an accumulation kind of thing, is the terminology they use in this situation. All right? So I tell you what, I said I was going to do the iPad, but I want to take you to, I've got a function here that I'm going to come back to the iPad and look at this function right here, the integral of the sine function. Okay? And one of the things they present, how they present it in the text, and this is something that's talked about in when they first talk part one of the fundamental theorem of calculus, is that if you've got a starting point and you're trying, it's an accumulation function, whatever x is going to determine how much area is under the curve and what that situation is. Let me show you one thing that they have they put into the text here. I'm going to do a new share. And they've got the graph drawn here in the text itself. I think I've got it. It's in a slide search situation here. And this is the graph I'm looking at. I'm not going to blow it up necessarily, but here's the idea. Look at this function. That is the sine function. And what's kind of cool about it is that it's symmetrical above and below the axis. So this kind of demonstrates something, but it's accumulating as you move to the right. So if we look at, I'm going to go in a second and I'm going to do 4 different integrals. And we're going to do the area under the curve from 0 to pi over 2, from 0 to pi, from 0 to 3 pi over 2, and then from 0 to 2 pi. And see what the end results are. It's an accumulation. How much is under the curve as you move along? So let's go back to, I'm going to go back to, I'll put that on the screen, and I know what's going on there. I'm going to go back to my iPad, and let's do this. So what I'm going to do is, picture the graph, you know, it looks like this. The sine function looks like this. And this point right here is pi over 2. Here's pi. Here's 3 pi over 2. And there's 2 pi. So first we're going to go 0 to pi over 2. And do the sine of x dx. Okay? So we're going to go, this is pi over 2 in the diagram. And what I'm going to do is I'm going to go to here. And I'm just going to check this area of the curve and see what we get. So let's do it now on our calculator if you want to. But before we do that, I can also use the fundamental theorem of calculus to calculate it. What's the integral of sine? Well, it is, right, negative cos. What do you take the derivative of to get positive sine? Well, if I take the derivative of sine, I get cos. So derivative of cos is negative sine. That means I've got to switch signs. So this is going to end up being negative cos x from 0 to pi over 2, right? From 0 to pi over 2. That is the integral using the fundamental theorem of calculus. I just calculated cap f. And now I need to plug in. So now I need, this is cap F from A to B. And now I need cap F at B minus cap F at A. All right. So, and we got to keep track of that minus sign that's out front. So I get minus cos of pi over 2 minus, what do we have there? That's negative cos of 0. Yeah? Okay. So now if you've got the unit circle down at all, we're going to go to the next step of this. Minus cos of pi over 2. Pi over 2 on the unit circle. Pi over 2 is up top. What's cos? It's on the x-axis. It's on the y-axis. X is 0. Cos is 0. So we've got this term is 0. And then we've got plus cos of 0, which is 0 plus 1, which is 1. So the area under the curve between 0 and pi over 2 is 1. All right? Now, it's symmetrical. The sine function is symmetrical. What do you expect it to be when you continue on to pi? Let's do this. I think this is a good example of some things. So the integral from 0 to pi we're going to plug in this time is going to, of the sine of x, dx, is going to be negative cos of x from 0 to pi this time. So now I've got minus cosine of pi minus cosine, there's a negative cos, right? It's crucial that you have the minus, keep track of your negatives. I got stressing there and I almost went away from it. So I got minus negative cos of 0 again. Okay, so what do we have this time? We've got minus cos of pi. At pi, we're out here. What's cos? Negative 1. So I've got negative 1. Minus a minus is a plus. Cos at 0 is 1, which is 1 plus 1, which is 2. So that means that when I'm going to go up here now and fill in this part under the curve. And that, notice I had 1, and now I added 1 more. And look what happens when I go down here. When I go to 3/2, let's just do this. I don't have to do them all, but I want to do this. The integral from 0 to 3 pi over 2 of sine x dx equals negative cos x 3 pi over 2, 0, which equals, okay, so I've got negative cos 3 pi over 2 minus negative cos of 0. Got to keep track of the minus signs, which gives us, okay, cos of 3 pi over 2. We're back here, okay? And what is the cos of 3 pi over 2? 0. So I've got 0 here. Plus, what's cos of 0 is equal to 1, excuse me. So let me just clear that out of there. That's 0 plus 1, which equals 1. So what we've done is we have taken away the area of that region is under the x-axis. So that's 2 minus 1. And it'll be obvious what the final answer is going to be when you go to 2 pi. Okay? So the answer, so the answer for this is 1. So we expect to take another 1 away, which means it'll end up being 0. So the integral, let's do the integral of 0 to 2 pi of sine x dx equals negative cos x from 0 to 2 pi, right? That gives us what? Negative cos of 2 pi minus negative cos of 0. Which gives us the cos of 2 pi on the unit circle is right there. The cos is positive 1. So we end up with negative 1. Yeah, that's negative. Cos of 2 pi is 1. Plus the cos of 0 is 1. That gives us 0. Good practice problem for keeping track of your signs, thinking about the whole thing. Plug each of those into your calculator. And there are definite integrals you should get 1, you should get 2, you should get 1, you should get 0, and you should get, go for that. And make sure you get 1, 2, 1, and 0 back. All right? Any other questions at all on that? So that's an example of accumulation. As you move to the right, you accumulate according to what's under the graph. Okay? And when you got out there far enough, became negative. On the sapling problems, there's water being poured into a reservoir. And that is given as the function. And it says how much water is in the reservoir. Well, that means you got it. It's a rate. So if you integrate that function, you'll get the area under the curve, which gives you how much water went into the reservoir. You got the population of insects. There's a function given for that. If you take the integral of that, the area under that curve will be the population of insects. The formula is the rate of change of how fast the population is growing. If you take the integral, you end up with how many insects have changed, how much change has there been from 0 to here, or from between whatever values you get. Okay? That's the accumulation kind of moment. Okay, any other questions at all?
I was just wondering if you already went in to change quiz 4, because right now it's still out of 100 points.
It's where?
It's out of 100 points instead of 20.
Oh, yeah. Very good, very good. I've had a few different people mention that. And it's not an automatic just jump in and make a switch. So I'm going through some technical perspectives to go ahead and change that. Absolutely. I'm aware of it. Thank you very, very much now. And thank you, everybody that's spoken up about it. I really appreciate it. Because quiz 4 is out of 100, that's going to blow your average out a little bit. And I'll make sure everything else is cleared up in the grade book as well. All right. So thank you for mentioning it. And it will be done. Hopefully it'll be done today. Okay.
Thank you.
Good. Any other questions about anything we've talked about today? We'll tell you what, we're closing down on 1 hour. And if you've got further questions in preparation for the test tomorrow, make sure you're conscious of the questions that have been showing up on the quizzes, the idea of differential equation with a boundary condition. That's a fair game. Area under the x-axis, fair game. Indefinite integral needs a plus c. And I'm going to include probably one question that's going to require substitution. And I will say, use substitution in the question, okay? In the future, when you get to Calc 2, you just need to solve them. And you're just going to need to know that's what you got to do. But the goal of this class is to make sure we touch this section and get familiar with the basics of some foundations of what substitution is. And so I'm going to make a point to include probably one question on this test and probably on the final, okay? So use the fundamental theorem of calculus. That means show your work, use the integration bar to show limits of differentiation, limits of integration, A and B, limits of integration, and come up with your final solutions across the board. Be able to round to 4 decimal places or whatever number I ask you to, and be able to give an exact answer. Like I said, some of you were thinking, I think, the longer you wrote the decimal, the more exact it is. And that's not correct. When it's an infinite decimal, if you stop, you've rounded, okay? So what I asked for, the exact answer, is in terms of that infinite, that item that is the infinite decimal representation, the pi, the e, the square root of 2, combination of all those circumstances are logs, ln of a number. Those all stay intact. Simplify as much as you can, but the ln needs to be in there and the e needs to be in there until in your final answer. As soon as you plug it into your calculator, you've rounded. Okay? All right, well, I'm going to stop there then. If you've got questions, I'll be over until 12:30 in the Zoom office hours. Thank you all for showing that those of you that are here. Again, if you've got questions, I'm going to linger as I'm fading here. I'm going to wait for you. If you've got a question you might want to ask, feel free. But I'm going to go ahead and stop the recording at this point right now.